Testing 1 2 3. Testing 1 2 3.
Okay. Am I on?
Or, and we're gonna try to hide the mic here. Look at to the time. Just give me a few test sentences.
Yeah. I tend to have kind of a deep voice. Testing 1 2. Chat, chat, chat. Hello. Hello. Getting the levels 1 2. Is this mainly for the recording or for the room?
For both. I'm gonna adjust it for the room.
Okay.
I'm worried about the recording.
Oh, okay. Because in a room like this, I don't really need a mic.
Yeah, it's gonna be fairly low once you start.
Right. Okay. Exactly.
Just
Yeah.
to capture your
Right. I tend to project fairly well. There we go. I can hear 1 2. 1 2 1 2. Testing.
All right.
How's this? You're all good?
Yep, sounds good. I'm
Okay,
gonna mute
great.
you for now. Testing 1 2. Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. Testing 1 2 3. Testing 1 2 3.
Yeah, be integrated in that acronym support. Yeah. Yep. I've done some stuff around trade, not around the banks. That's fascinating.
You're hiding the fact. You shouldn't do that. That's the second most important thing in the.
We're good. Yeah, we've got this.
Testing 1 2 3. Testing 1 2 3.
We've got some funding through middle of next year, so now we're on the hunt again. Right. No, so this is our make or break few months. Yeah, okay, which is interesting stuff. Largely around communications, on carbon removal approach, so on work with the NGO community. Apparently.
right up there.
Yeah.
Are you doing an intro?
Yeah, hold on, we can try. Hey, appreciate it. Thank you.
Work my way up. It's tempting, but
Are these your notes?
there was one part there that
Is
I'm
your Trumpian?
right. No quid pro quo.
Oh my God. Good morning, everybody. Rafe is here, so we can begin.
I'm leaving.
Thanks for coming.
My name is Simon Nicholson. I direct a group called the Forum for Climate Engineering Assessment at American University. We're pleased to welcome today Jesse Reynolds. I'll introduce Jesse in a moment. We're co-hosting this event with our friends here at the Center for Science, Policy and Outcomes at Arizona State University. Thanks again for hosting us, folks. It's always a pleasure to collaborate with you. Arizona State is doing a lot of interesting work in this area of solar geoengineering consideration. There's a report at the back of the room for those of you who are here in the room, titled Cooling a Warming Planet, Public Forums on Climate Intervention Research, which was just released a couple of weeks ago, based on some public deliberative work that this group here in Washington, D.C. has been performing. Let me give that to you.
Thank you.
So that I can hold up Jesse's book, which is what we're really here for. This new book by Jesse Reynolds is titled The Governance of Solar Geoengineering, Managing Climate Change in the Anthropocene. Jesse is, let me get the title right, an Emmett Frankel Fellow in Environmental Law and Policy at the University of California, Los Angeles School of Law, and has many other affiliations. He's one of the world's foremost experts on solar geoengineering law and policy, and has a wide portfolio that extends beyond that. Jesse's going to speak for, let's say, 45 minutes or so.
At most, hopefully.
Yep, and then plenty of time for conversation. So welcome, everybody, and thank you, Jesse, for joining us.
Thank you, Simon, for the kind introduction. Right, so I'll try to keep my talk relatively brief. I think our time would be better spent with questions and answers about climate change, solar geoengineering, its governance, and my specific proposals therefore. So the context of solar geoengineering is anthropogenic climate change. Climate change that is caused by our emissions of greenhouse gases. And really the crux of the relevance of solar geoengineering can be captured in this 2x2 matrix that I am kindly borrowing from Rob Sokolow, a professor at Princeton. And it has two axes. Is climate change an urgent problem? Yes or no? Is ending the use of fossil fuels, which will be essential, arguably the core step of preventing anthropogenic climate change, will that be difficult or relatively easy? And you end up with a 2x2 matrix in which climate change, if it's not urgent or fossil fuels is not difficult, then the transition will happen on its own time. Where if climate change is not an urgent problem, but ending the use of fossil fuels is difficult, why bother? And that tends to be the position of certain skeptics of climate change, contrarians, those who resist reducing greenhouse gas emissions for one reason or another. Then most environmentalists, most of those who are concerned about the risks of climate change say it is an urgent problem, but we can do this. It's not as difficult as we think. But the underappreciated high-risk box, shall we say, is that climate change is an urgent problem, but ending the use of fossil fuels is difficult. That's where I am personally, and even if you are in the environmentalist box, in which climate change is an urgent problem, but you think that it would be easy to end the use of fossil fuels from a risk aversion standpoint, you want to think, well, but maybe it will be difficult. So what are the other options? So for a few slides, I'm going to make the case for the right-hand column. I'm not really going to address the the difference between the rows. I'm going to assume henceforth that climate change is an urgent problem, but make the case that ending the use of fossil fuels and otherwise reducing greenhouse gas emissions will be difficult. So greenhouse gas emissions the most important greenhouse gas is, of course, carbon dioxide, and its most important source is the generation of energy. So let's look back and let's look forward. First, looking back at the sources of energy, here are the world's sources of energy from, for the last 45 years or so. And the top four colors, the yellow, light blue, orange, and a tiny sliver of red, are low carbon sources. Whereas the bottom three thick bars are fossil fuels, coal, oil, and natural gas. And while the zero carbon sources or low carbon sources have been increasing at a relative level, at an absolute level, or relative to their own past, shall I say, as a portion of total energy, it's actually decreasing. And we hear a lot about the rapid increases in solar and wind power, but those are part of the red slice, which is barely visible on this graph. Yes, solar is doubling every, I'm not sure, every 5 or 10 years or something like that, but the baseline is so low that it is unable to keep up with the growth in energy demand otherwise. So looking back, this is one reason to believe that ending the use of fossil fuels will be difficult. Now let's start to look forward. Here we have actual greenhouse gas emissions. I skipped an essential point that's actually on both sides. The red vertical line, let me explain that. That's the UN Framework Convention on Climate Change, the first global international treaty to prevent climate change. And that can be a demarcation in time in which the international community recognizes that climate change is real, poses risks, and is resolved to reduce and eventually, hopefully, eliminate net greenhouse gas emissions. So here you have something of a before and after with, in my assessment, not a dramatic effect on the production of zero energy sources. Okay, back to here. The Framework Convention is there as the vertical line. The black dots, the thick black dots, are actual greenhouse gas emissions from energy and all other sources. So carbon dioxide from energy, carbon dioxide from land use changes. There's a handful of other greenhouse gases such as methane. This is somewhat more comprehensive. Coming from 1980 up until, I believe the data here includes estimates for 2018. And you can see it marching steadily upward. Just yesterday, I asked what that blip in 1997 is, the little spike in 1997. That was the largest forest fires in recent history in Indonesia. I had forgotten about these, but in 1997 to 1998, there were massive fires in Indonesia that are significantly visible on total greenhouse gas emissions. Actual emissions march steadily upward. All the various lines that are branching off and forming something of a cone are the high-level scenarios that the Intergovernmental Panel on Climate Change, the world's leading scientific assessment body for the causes, the forecasts, the risks of climate change. These are the headline scenarios that they have used over the years, starting, I believe the scenarios were first generated in 1990. We're currently using the relatively thicker lines, the so-called RCPs, representative concentration pathways. A new set's being developed now that's not yet on this graph. But we have almost 30 years of history now of generating scenarios of the future, but then moving into that future. And what I observe from this graph is realities has been on the more pessimistic side of the scenarios. We've tended to track on the higher end of our range of projections. Further evidence, in my opinion, that ending the use of fossil fuels and dramatically reducing greenhouse gas emissions will be difficult. What about the future? The recent Paris Agreement of 2015, another international climate change agreement, in it, the world agreed. All countries of the world have, nearly all countries of the world have ratified this agreement and agreed to keep global warming within 2 degrees Celsius. Because carbon dioxide accumulates in the atmosphere, a given amount of warming implies a budget over time. We could use that quickly, we could use that slowly, but it's really, it's like having a line on the bathtub, and if you turn down the rate of the faucet, it's still eventually going to fill up just a little bit more slowly, perhaps. If we want to stay within 2 degrees warming, emissions are going to need to do something like this. Different assumptions will lead to slightly different endpoints of when emissions need to be 0, 2050, 2060, 2065, something in that neighborhood. But it implies a dramatic, fast turnaround of a very large, very complex global system that's intricately involved in almost all modern human activities, further implying the difficulty. You may also know that the Paris Agreement operates in 5-year cycles in which countries of the world make voluntary commitments to their emission reduction activities. They're voluntary, but they're also taken quite seriously. They're made public. And not meeting them would bear something of a reputation cost. We're currently on the first cycle of such commitments, which came out with the 2015 Paris Agreement. If countries keep those commitments, if they meet those commitments made in 2015, some countries are on track, some countries aren't, something like that will happen through the year 2030. Global emissions will continue to increase, but at a slightly lower rate. That's not encouraging. Finally, let's look to the end of the century. An interesting paper came out just a month or two ago in which 50 or so experts in scenario planning, energy, transitions, climate change forecasting, integrated assessment modeling, et cetera, were asked, where do you really think we'll be in 2100? Right? This was anonymous, so they could say, they could be honest, let's say, hopefully. And roughly the median answer through a handful of different questioning points to something like that. This is the median answer among experts saying, where will we be in 2100? It's not actually that line, it's really just the point at the end of the line. It's probably would actually be more of a hump with some area under the curve, and how steep that hill goes up and then steep goes down would have further implications for how much CO2 has accumulated in the atmosphere. That's further to say that the forecast is not encouraging. You'll notice here at the bottom, though, I say 2 degrees without CDR. What's CDR? CDR is carbon dioxide removal. There's a range of technologies that could remove carbon dioxide from the atmosphere and store it safely in a variety of locations. These could contribute to reducing net emissions. We can now speak of net emissions because we'll have some emissions and some removals. But what's happening is, as emissions have continued to increase, but we still have the same budget to reach 2 degrees, or to stay within 2 degrees, let's say, then the assumptions of carbon dioxide removal in the future have increased. It's like having a fixed budget, but living a bit above your means by using your credit card. For a modest amount, that can be a successful strategy. A student might take out loans, perhaps even putting some of the cost on a credit card with expectations of changing conditions in the near future. But the magnitude of assumed carbon dioxide removal in current scenarios that keep us within 2 degrees warming, such as this, are enormous. This gets us to something like 15 gigatons per year, which is very big. It's a hard number to wrap your mind around because gigaton is not something we use in our daily lives. As a reference point, global food production, which is one of the most massive undertakings that humans do. We can kind of imagine this, all the crops in the world, all the cattle, all the sheep, etc., that's moved around the world is on the order of 3 or 4 gigatons per year. So this is assuming the development of an industry that would move mass several times greater than the total food production of the world right now. It's a risky gamble. Carbon dioxide removal can contribute to lower net emissions, but this is a risky gamble. So some scientists and others ask, are there other options? And the inspiration for what has become known as solar geoengineering comes from volcanoes primarily, because volcanoes cool the planet naturally. They release, in addition to lava and so forth, they release large amounts of particulates, dust, some of which linger in the atmosphere for months or well over a year. The smaller particles linger longer. Those that are emitted higher linger longer. And it blocks a significant portion, significant in the measurable sense of the word, of incoming sunlight, reflecting a small portion, let's say 1% or so, of incoming sunlight back into space. And a large volcano such as this is Mount Pinatubo in 1991 in the Philippines will cool the planet by, let's say, a degree Celsius for a year or so. And then the small particulates gradually settle to the Earth from often in the stratosphere, starting above where weather happens, eventually settling down, getting captured by rainfall, and coming down to the ground. So some scientists and others are exploring the possibility of artificially simulating the cooling effect of volcanoes as a means to reduce climate change. The leading proposal for such solar geoengineering would be to inject an aerosol, a fine mist or a superfine powder, into the stratosphere, roughly 50% greater or double the altitude where commercial aircraft fly, to give you a sense of the altitude. Injecting a few megatons per year of a material such as sulfur dioxide, which is the primary material that volcanoes emit, because we know it works in the climatic sense of the word, in the rough sense of the word, or another material into the stratosphere, blocking 1 or 2% of sunlight, cooling the planet by, let's say, a degree or 2 Celsius. This diagram here shows the use of a tethered balloon. Research currently points toward modified aircraft as being the most feasible and economically efficient means to deliver the aerosol into the stratosphere. There are other means of delivery. That seems to be the most promising one. And there's also other means of solar geoengineering that are being considered. But stratospheric aerosol injection, in my opinion, by a significant margin, has the most potential to counteract climate change globally with some predictability of effects based upon our experience with volcanoes. Does it work? Would it work? In the gross climatic sense of the word, it would. The IPCC, the Intergovernmental Panel on Climate Change, says that there is high agreement that stratospheric aerosol injection could limit warming to 1.5 degrees Celsius. That was used as a benchmark because this was a special report on 1.5 degrees warming, which is a second, more ambitious target that the Paris Agreement contains. Let's stay here for a moment. But by work, I mean in a gross, I use the word gross or blunt climatic sense. It would cool the planet, and it would reduce precipitation changes, regional precipitation changes caused by climate change if the use of solar geoengineering were moderate. If one were to use solar geoengineering to counteract climate change halfway or 3/4, some regions would experience more or less than that global half or 3/4. But that would nevertheless be in the direction of returning regions to pre-industrial conditions. If one were to use solar geoengineering to fully compensate climate change, particularly under highly elevated greenhouse gas conditions, then you would likely have regional climatic anomalies, because some regions would be overcompensated, some regions would be undercompensated. You'd have 105% and 95% compensation, particularly on the precipitation effects, which for both climate change and for compensation by solar geoengineering are a bit more unpredictable with wetting here and drying there. So it's important to emphasize what I mean by the gross and blunt expected effects that we know from volcanoes, from modeling, as well as from the local level. That's the occasion, the reason that I have this wonderful image of what I believe to be Los Angeles under smoggy skies, is we have further effects of the effectiveness, the cooling effectiveness of aerosols from low-level pollution, which is also dominated by sulfur dioxide aerosols. When it stays locally from air pollution, it has a cooling effect, a significant local cooling effect. And right now, low-level air pollution is cooling the planet. It appears to be masking approximately a third of climate change to date. It may be more, it may be less, but it's something like that. And an ironic, undesired side effect of cleaning up ground level or lower atmospheric air pollution, which is hazardous for our lungs and for our health and so forth, is that previously suppressed climate change it will be manifesting, and that's probably already happening right now, in part because China's cleaning up its air, for example, and the U.S. has done a pretty good job over the last 50 years of reducing ground level pollution. So that's a third set of evidence, shall we say, for the cooling effect of aerosols, volcanoes, models, and ground level aerosol. So let's start shifting the conversation into thinking about governance, the topic of my talk today, the topic of my book, and to understand the governance needs, challenges, and opportunities of a phenomena. We need to understand its broad characteristics. What is this thing we're talking about, this solar geoengineering thing? What could it do? What are its core characteristics? First, the idea is not to substitute and replace emissions cuts, but to complement them, because steering the ship, so to speak, imagine that the global energy system and economy is a heavily laden cargo ship, and steering it on a slightly different course takes time because there's a lot of momentum behind that. Ideally, solar geoengineering could be a complement to that, reducing climate change and climate change risks in the meantime as we turn the energy system around. Complement, not substitution. Climatically effective, I have described that. It would also be fast, relatively fast in its effect on the time scale of a handful of months, let's say. We know that from volcanoes, which cool the planet in the year following a large volcanic eruption. And that can be particularly effective from a risk management perspective because reducing and preventing climate change through emissions cuts, so-called mitigation and carbon dioxide removal, will take decades, if we're lucky, to turn that ship around, whereas solar geoengineering operates something like a speedboat, if you will, on the waters. And in the meantime, we can reduce short-term risks in principle through solar geoengineering. It's reversible in its direct climatic effects in the same way that the cooling effect of volcanoes lasts a year, year and a half, maybe 2 years. If solar geoengineering were used, and we, whoever we may be collectively, whatever decision makers may be, decide that less intervention would be desirable. Perhaps we've finally reduced greenhouse gas concentrations through the ending of emissions and the use of aggressive carbon dioxide removal, that we want to dial it back. Or maybe solar geoengineering turns out to be more effective than we thought it was in terms of the cooling effect per mass injected into the stratosphere. It's reversible in its direct climatic effects. You reduce the amount being injected, and a new equilibrium would be reached within the time scale of months to a year. Geoengineering is necessarily global in effect. This has very important consequences for governance. Certainly, stratospheric aerosol injection, the leading proposed method of solar geoengineering, is global in effect because aerosols mix fairly rapidly in an east to west direction and less rapidly north to south. They gradually migrate toward the poles. You might be able to get some degree of latitudinal optimization, but really not much in the way of local cooling. Some of the other proposed geoengineering methods, such as marine cloud brightening and cirrus cloud thinning, may be able to have some limited temporary local cooling effects that could be used to possibly be used to manage local extreme events, but that is highly uncertain as to whether the ability for that to happen. Solar geoengineering appears to be remarkably inexpensive in its direct financial costs of implementation. To give you a sense of how inexpensive in terms of climate change economics, relatively speaking, when we speak of the impacts of climate change or the cost of significantly, substantially, aggressively reducing greenhouse gas emissions, we talk about numbers in the trillions of dollars per year. Whereas the direct financial costs of implementing solar geoengineering appear to be on the order of a few $billion per year. 1, 5, 10, the numbers seem to come back in that area. So we're talking about a fraction thereof. Now, costs might, of course, be higher because we'd also have monitoring systems and research and development beforehand and so forth. But it's so inexpensive that the cost is almost insignificant. And whether that's a feature or a bug depends how one looks at it. Because the combination of low cost and global in effect means that it's highly leveraged to the point that a number of actors, probably states, countries, could move forward with global implementation with or without international consensus in that area. There are a variety of physical and environmental risks related to solar geoengineering. I've mentioned precipitation, particularly precipitation anomalies, also cooling and warming, but mainly concerns around precipitation anomalies as solar geoengineering would mask more and more climate change. One would become concerned about precipitation anomalies. There's also concerns around interaction with protective stratospheric ozone, for example. And there are a diverse bundle of issues that I call social challenges. The line between an environmental risk and a social challenge is not clear because many of the things that I call social challenges are socially and politically mediated environmental risks. But let's unpack this box a little bit further here. The leading concern of solar geoengineering is that its consideration, research, and development would undermine our efforts towards reducing greenhouse gas emissions. That's why it has an asterisk. It's a leading concern. Some argue that significantly investing in solar geoengineering could create a slippery slope towards deployment through the creation of vested interests or changes in values and norms and expectations. We would need to govern and regulate essentially unknown environmental and social risks. This is an endeavor we haven't done before. We've not done anything like this before, yet obviously we should have governance before the use of solar geoengineering. There's questions around disagreement and decision-making of solar geoengineering. If it is in fact so financially inexpensive, and I didn't mention that it is also relatively technically simple to inject an aerosol into the stratosphere. Doing it right might be difficult, but doing it in the gross sense of the word appears to be fairly technically feasible and simple. And global in effect, who decides and what do we do with disagreements? The distribution effects might be uneven, which could lead to finger pointing and blame for perceived or real harm from solar geoengineering, such as extreme weather events. there is, just like the low cost of solar geoengineering is both a feature and a bug depending on how you look at it, the reversibility of solar geoengineering also has significant advantages and disadvantages. The advantage being you can just, one, the decision makers, whoever that may be, could back off of it. The disadvantage is that if solar geoengineering were stopped for some reason and not resumed, you would have the expression, the manifestation of the previously suppressed climate change quite rapidly. That would be even more dangerous than had the planet warmed up gradually all along. And there's a whole host of concerns that I bundle under the single word ethics. Is this how we want to relate to nature? Is this how we want to use our technology? Is this an appropriate vision of the future in the 21st century? Is it an appropriate means to use technology for a relatively small number of decision makers on the planet to alter the natural environment for everyone on Earth? Is that morally acceptable? So it's for these reasons I get the sense, for example, in the IPCC report, that the real concerns around solar geoengineering are less its physical and environmental risks, which appear to be manageable, relatively low to climate change, for example, and perhaps acceptable, but it's these social challenges, these governance concerns that raise more alarm bells. Let me hop back one more slide. There's 3 asterisks here on these social concerns. These are the 3 that I'm going to touch upon more in a minute. Should have said that there. In terms of my governance proposals, I will in a moment be discussing undermining efforts towards mitigation, decision-making and disagreement, and termination shock. Apologies for that oversight. So it's these social concerns that raise a lot of alarm bells. The IPCC says that solar geoengineering faces social and institutional risks related to deployment. Some writers, such as Mike Hume, who is an academic in England, fairly highly regarded, he goes so far as to say that solar geoengineering is ungovernable because we do not have, what does he say, plausible and legitimate processes for deciding who sets the world's thermostat. And it's these sets of issues that motivated me to write my book, which Simon so kindly highlighted. I have a copy here if you wish to browse it after the talk. And this is just a selection of the perspectives or views or lenses through which I look at the problem and challenges and opportunities of the use and research of solar geoengineering, as well as a handful of the specific issues such as liability and compensation and intellectual property. What I'd like to do now in my talk is then move into the question of how specifically could solar geoengineering be governed? And to respond to Mike Hume, is solar geoengineering ungovernable? And I think it is not ungovernable, that solar geoengineering could be reasonably, effectively, feasibly governed, because even though it would be an action, a phenomena, a set of activities fundamentally unlike anything we've done, raising a host of novel social challenges, these novel social challenges are not fundamentally unlike anything that we have collectively governed, addressed, and managed in the past. So the first one I'm going to talk about is decision-making and disagreement. How might we decide whether and how to use solar geoengineering? Related to this is a lot of attention given to the idea of a moratorium on the use of solar geoengineering or the large-scale research in the meantime. This is ideally, I don't think there's any disagreement that a moratorium could be beneficial. The challenge becomes in who implements it, based upon what criteria, and then most importantly, who decides whether those criteria have been met in order to lift the moratorium. So I'm unsure whether this would be an effective means to control decision and disagreement. because part of the fundamental challenge around here is that it's a question of constraining state behavior. I'm going to be talking a lot about countries from here on out, countries or states, to use the term preferred in international relations scholarship. If solar geoengineering is technically feasible and financially relatively low cost, it's within the capacity of a handful of states to roll out on their own. We have to constrain their behavior, but international law is consensual. States have to agree to have their behavior constrained. So I think pointing calls for some sort of centralized decision-making body that operates on a sense of global consensus about whether and how solar geoengineering should be used are misguided from a sense of just the nature of the international order. Those countries that are most interested in using solar geoengineering wouldn't join. Why should they constrain their own behavior? The international order operates through more or less a system of voluntary promises, and those promises are made when there's something to be gained for that state. So I have sort of two visions here. A relatively optimistic one would point to an international institution that must have among its participants those states that have the technical capacity, the financial resources, and the political willpower to use solar geoengineering if it came down to international disagreements. It must get those states on board, even at the cost of firmness of commitments. So instead of saying, I don't see such an institution saying, you may not use solar geoengineering unless we decide that it may. But instead, create aspirational norms, shall we say, with language such as should, in which an expectation is given that a state that were to use solar geoengineering outside of such an institution is violating international norms, but has not made a firm commitment not to do so. And that such use of solar geoengineering should abide by a range of best practices: prior environmental impact assessment, consultation with potentially affected parties, et cetera. And it might be desirable that such an institution recognize that states have a right to use solar geoengineering in order, for example, to protect their populations from clear, severe risks of climate change. This might be the carrot that entices states to participate in such an institution, that they get political cover, that if push comes to shove domestically, they could take such action in terms of a compromise. I'm going to skip over those aspects of it for the sake of time so I can get to my other issue. But I would also like to point toward my less optimistic, less cooperative vision in which the world could manage decision-making around the use of solar geoengineering that doesn't rely upon a global body that may make decisions with some allowances for states to operate outside of it, but instead looks at something less centralized around decision-making. And I've been thinking a lot about global monetary policy as perhaps one of the better analogies for the use of solar geoengineering. This is an area in which states make decisions that have impacts globally, where states have unequal power, where states with larger economies, such as the US and Europe, when they do things like adjust interest rates, there are states with currencies pegged to the dollar and to the euro. There are states that trade so much with the US or with Europe that the effects on their economy are substantial and within some degree predictable. But we don't have a global body that is setting worldwide monetary policy or dictating national policy. We have an IMF that monitors conditions, it conducts research, a forum for sharing information transparently, some minimal level of coordinating national policy. It offers advice, it builds capacity, and it responds to emergencies. So maybe that is a better, more feasible target for making decision-making, for making decisions around solar geoengineering. In the interest of time, I will go through my last slides somewhat briefly, and I'm glad to get into them in more detail if there's interest after I wrap up. So I said I would address 3 leading challenges of solar geoengineering, the first of which is decision-making and disagreement, the second of which is the concern that the consideration, research, and development of solar geoengineering would displace, would push away, would weaken and undermine efforts towards reducing emissions. That's called mitigation in the climate change, climate policy lingo. So I call this concern mitigation displacement. This has had a demonstrable hindering effect on the research of solar geoengineering. And I'm confident saying that this is the leading concern about expanding research of solar geoengineering. The IPCC, for example, says we don't know what to do. So I'm working on a paper. This is not in my book, this part here. I'm working on a paper right now with my colleague Ted Parson at the UCLA School of Law, where we turn to international strategic issue linkage as a model for thinking, could we link mitigation policy with decision-making on solar geoengineering in such a way that it minimizes any mitigation displacement, which we consider to be more or less synonymous with giving states incentives to increase mitigation. Because, of course, we'll never know whether mitigation has been displaced. That might be happening right now, for example, with attention towards adapting to a new climate, which is another response to climate change that has been fully elevated in the international climate change discourse. It doesn't reduce greenhouse gas emissions, and it might be pushing away and displacing mitigation. We don't know. And there's, in fact, really no way to know. So we're thinking about, is there a way that an international agreement feasibly could link these issues in a way to give states the incentives? And to briefly summarize it, it involves a set of states, 1, 10, 50, or 100, declaring that they have a right to use solar geoengineering. Done responsibly, that's not contrary to existing international law, but only if they meet their own emissions targets and the other states that are outside of this unilateral declaration, if you will, don't meet their targets. Okay? This could be rephrased looking from the other direction, that these states promise to relinquish their claimed right to use solar geoengineering if either they fail to meet their own targets or if the rest of the world does meet their targets. So we end up with kind of another 2x2 matrix in which the only box in which members retain the right to use solar geoengineering is when members abate, which means reducing emissions, another term for mitigation, and non-members don't abate. And under certain circumstances, this might give all the actors some degree of motivation to step up their mitigation efforts, because the states within the coalition want to retain their right to use solar geoengineering without going back on their promise. Of course, they could renege on their promise, but they would prefer to retain the right, whereas the states outside the coalition would presumably not want the coalition to go forward with solar geoengineering. That's a presumption that may or may not hold, but if we presume that, then it gives everybody the motivation to step up their mitigation through issue linkage. And then skip that. I could come back to that. Glad to come back to that. Third is termination shock. What can we do about the risk of termination, that if solar geoengineering were to be used at a high capacity, at a high level of intensity under elevated greenhouse gas conditions, and then it stopped suddenly and not resumed for whatever reason, that real serious climatic impacts would manifest. That's real. And drawing on some work I initially did with Andy Parker and Pete Irvine, and then they later expanded 2 years later, we need to think this through, that if solar geoengineering is inexpensive and technically feasible, and ending it would cause severe impacts, then it seems that that an implementer could not unilaterally suddenly end solar geoengineering, because someone else could resume the action. So it points toward the necessity, the importance of having geographically distributed, redundant infrastructure and knowledge systems, as well as having reasonable safety precautions to protect this infrastructure and knowledge system. Because after all, there are a number of global complex systems that we presently rely on that if they were to suddenly stop and not be resumed, that would cause widespread negative impacts. The generation of energy, for example, food systems. If these were to suddenly stop, if international trade were to suddenly stop, the impacts would be severe. But we have geographically distributed infrastructure and knowledge and reasonable protection against that, against harms, that it seems that the sudden cessation of solar geoengineering, when all actors know that doing so would have severe effects, seems unlikely. And if the implementing actor or others did wish to end solar geoengineering, for whatever reason, would know that it's in their best interest to slowly ramp it down over the course of a few decades. I'll leave it at that, given the amount of time we have. I'm glad to go into more detail on the three aspects that I emphasized, or others, or really any questions around solar geoengineering and its governance.
We have a couple of hours.
Yes.
Thank you. Oh, online, there's an audience? Okay. Thank you for a great presentation.
Thanks for coming.
Yes, I'm glad I did. I have a question about this focus, the great focus on governance. I've been in this field for a long time, and there are a lot of passionate people involved in governance. But let me put out an outrageous thought. Governance is not the problem. You've already figured it out. The problem is political will and understanding the risks. Question, how do you bring the Russians on board? Because they seem to think that having the North Passage, the northern passage across Russia open is in their interest, as opposed to the melting of permafrost across Russia. Well, I give that as an example of a sort of a geopolitical question. That's one. But second, I guess you identified it, does it get in the way of mitigation, right? That's another political problem.
Yeah.
But, so what I wanted, in the scholarship around geoengineering, people ignore the political piece of this. It's cheap, it's quick, you know, international negotiations can do as you suggest. So why not more attention to the politics of it? That was long-winded, but.
Thanks, Rafe. There were at least 2 points there that I'd like to respond to, maybe 3. I agree that the governance issues perhaps sometimes receive, the long-term governance issues sometimes get more attention than necessary, despite the topic of my book, because the decision right now is not how we would make decisions about whether to use solar geoengineering. The question right now is, do we research solar geoengineering? which is occurring right now at quite a modest level, right? You probably know this, but to give a sense of what's going on, global climate change research total is on the order of $7 billion per year. I haven't got to put that down, but that's an order of magnitude, whereas solar climate engineering research is receiving maybe $10 million per year, so a small fraction of that. And there's been a lot of concern about ramping it up, but I think a lot of the concern about ramping it up is resistance around these long-term issues. Are these long-term issues ever resolvable? And if they're not, then why would we ever increase our magnitude and focus towards programmatic research of solar geoengineering? So part of what I'm trying to do in my book and in my talk here is to say those long-term issues appear to be manageable. Here's one way we could do it, maybe there's another, but I don't see any deal breakers, whether it's the mitigation displacement issue or the decision making. And then to circle back around about the Russia issue specifically, the politics, I fully agree that some of the international decision making issues are complicated, but I would assert they're manageable. And to give you an example about the Russia issue, the interesting thing about solar geoengineering is if it is indeed relatively inexpensive, technically feasible, and global in effect, it gives relative power to those countries that would want to use it versus those countries that would not want to use it, right? Or those countries that would want to use it at a greater degree of intensity. You can put more stuff in the sky, but you can't take the stuff out of the sky. So it puts at a relative advantage those countries that are most vulnerable to climate change, largely being developing countries, and it reduces in this domain space the relative power of a country like Russia, a world superpower, arguably still a seat on the Security Council and nuclear weapons. So how does a situation, for example, if a coalition of developing countries is either undertaking or pushing for solar geoengineering, let's say a coalition of developing countries that includes India, which has nuclear weapons and a relatively large military and 1 billion people and the technical capacity to use solar geoengineering and is vulnerable to climate change, and Russia is resisting this. My sense is it's not the type of thing that countries are going to go to war over, but it is the type of issue where countries will deploy non-military means of pressure, be it economic pressure or development aid and these sorts of issues. At the end of the day, it might get pushed into the UN Security Council, which is in a way the international forum of last resort, where countries like the Soviet Union have veto power. And what a veto means is unclear, whether the resolution, such a possible resolution, would be framed as a condemnation or a support of solar geoengineering. There's just a lot of uncertainties around which way the winds would blow on climate politics, but if the climate impacts are really severe in India in 20 or 30 years, which I think is not out of the question, when you have a drought or an extreme monsoon and crop failures in a country with 1 billion people that is rising out of extreme poverty, and there's ground level, on the ground agitation to do something to end these impacts, you could imagine a lot of worldwide sympathy for India. Please, Rafe.
I think another missing piece, which you just touched on, these discussions is specific benefits of geoengineering. And you just described one, which is to, let's say, the heat in India. Heat, avoiding it, allowing it to get too hot. For the United States, it might be sea level rise. Are we going to let Greenland go? Or how far? And how many cities are we going to allow to be taken out unless there's an intervention? So that's a concrete benefit. And the geoengineering debate doesn't really specify those very often, which I think is a critical piece, benefits. Final, I have a proposal for your international effort. a sea ice reserve. What's a sea ice reserve? You declare the 79 sea ice extent as a reserve. Well, what does that mean? It means it's a signal that governments may grow the ice back with Pinatubo-like intervention.
Yep.
So that tells all the developers the ice may come back and beware. And what that does is then sort of triggers a debate.
Yeah. I guess we'll go front in the black, front in the pink, and then in the back there, in that order.
I enjoy your talk, but I share your pessimism. A couple questions. One is a little more technical. You emphasize how fast it can go and stop, but I don't think it's so fast to refreeze Greenland, no matter how fast you stop the particulate. If you want to comment on that. But more to reality, pessimistic question. In today's geopolitical and even domestic political environment, could you even create international organizations? I doubt if IMF or even International Postal Union or telecommunications or World Trade or any of these effective international bodies could be created in today's geopolitical climate. Can you comment on that?
Yeah. On your first comment about sea ice and terrestrial ice on Greenland and Antarctica, yes. So the sea ice in particular is a lagging phenomena. It lags behind temperature, which then lags behind greenhouse gas concentrations. The ice that we have now is due to the conditions that were there over the past hundreds of years because ice takes so long to accumulate. So the challenge with what Rafe suggested around saying 70, the ice extent at 79, although sea ice regrows more rapidly, you were talking about sea ice and he was talking about Greenland, so I do want to make that differentiation. The terrestrial ice lags to the point that if we really wanted to protect sea ice, we need to be rolling out solar geoengineering now and not in 30 years when the impacts on India are severe. And that's a tough political sell because you're preventing something that people haven't yet experienced, but this vision of stuff in the sky might disturb, understandably, quite a large number of people. So that's a serious challenge. The sea ice is a difficulty in the way that like extreme heat is not, because the prevention of extreme heat is relatively rapid in effect. So thanks for that comment. In terms of political feasibility, my quick reading is that let's point toward my less optimistic level of cooperation, my vision of an IMF-like forum for some degree of coordination and information sharing. Such a forum need not be in place before solar geoengineering were to happen. Imagine a world in which we have a handful of actors intervening in the climate with some degree of transparency and some degree of coordination, but not enough. It then becomes in their own interest to start to network because they're going to be they would benefit if they're aware of each other's activities, if they exchange information, if they agree upon at least revealing and announcing the type of their intervention before they take it so that others can know. Go ahead and respond, please.
In response to that, the most optimistic scenario there, of course, is Antarctica.
Yeah.
Because Australia is in such a bad state, and that'd be the most affected country if you started something down at the southern pole.
Yeah.
And that would very limit it to the rest of the globe because it's mostly east-west.
Yeah.
And it would get a country who's most interested started.
Yeah. Right. And starting to point to particular countries that are doing implementation further emphasizes what I'm saying about it's in their interest to do some degree of coordination, because what could be a severe challenge with the use of solar geoengineering is hemispheric balance. So imagine that a country in the north or southern hemisphere is deploying solar geoengineering. It needs to be more or less at the same magnitude of intervention in the other hemisphere, or you could get a hemispheric imbalance in energy, and that exacerbates extreme weather events. That's an argument where you might want to have the northern and southern hemispheric countries coordinating at a minimal level in their own interest. So let's move on to the back.
You'll have to bear with me. I'm probably one of the least informed people in the room on the subject, but it's been fascinating to learn about it. I have three questions. One is fairly abstract and the other two specific. At the most abstract level, in your original taxonomy, you indicated sort of two basic perspectives, but as an observer, it seems to me there's a third perspective, which I would describe as winter comes, winter goes, the monsoons come, the monsoons go, the earth warms up, the earth cools down, get over it and learn to live with it. And you may dismiss that perspective as utterly ill-informed or so small it's inconsequential, but I would guess that probably half the 60 million people who voted for Donald Trump take that view. So it seems to me it at least deserves to be acknowledged and dismissed. And I didn't hear, let's say in fact, it may be what happens. We do nothing and learn to accommodate whatever's going to happen and then wait 20,000 years for the next ice age, or who knows. But two specific questions. One is, isn't there a UN agency, the World Meteorological Organization? Aren't they the logical place to do what you're describing? And the specific question is, what is the state of international law today of the emittance of pollutants or anything in the stratosphere over the high seas? It's outside of territorial waters. It's not in outer space. And I would imagine that if I started dumping poison off the coast of Russia, or if Russia started dumping poison off the coast of the United States in the stratosphere, we would send armed forces to stop it on the grounds that you have no right, even though it's over the high seas. So I don't know what the state of international law is in protecting the stratosphere outside of territorial airspace.
Okay, great. Two great. Let me address the specific questions. In terms of the World Meteorological Organization, the WMO, to that I would add UN Environment Program, formerly UNEP, as logical locations for early conversations about potential international coordination or even cooperation in the climate intervention space. Those are the two institutions that got the IPCC off the ground, and I think it was only UNEP that got that was the catalyst for the UNFCCC, the UN Framework Convention on Climate Change. We also now, in addition to those, have an IPCC that could perform more assertive synthesis and assessment of current evidence of solar geoengineering, and I think that's an area that's been lacking. And we have the Conference of Parties of the UN Framework Convention on Climate Change, which, although solar geoengineering does not necessarily fall within its scope in a strict reading of the objective of the UNFCCC, which is controlling greenhouse gases, it's close enough that the UNFCCC, Conference of Parties, could provide some guidance. So we have at least 4 existing international institutions where such conversations could start and arguably should start in the next few years. That's starting to happen in UN Environment specifically. It got off to a rocky start earlier this year when there was an introduced decision around assessing the opportunities and risks and governance options for geoengineering in general, both solar geoengineering and carbon dioxide removal, and it quickly became divided, and I think it points towards, among other things, in a lack of knowledge among decision makers around geoengineering, and specifically solar geoengineering. Your second question around existing international law of let's say, the introduction of a material that might be a pollutant above areas beyond national jurisdiction. Let's call it that. That's a... Not in outer space. Right. Okay. So it turns out that existing environmental law does a pretty good job of catching such phenomena. So for example, the atmosphere above the high seas is considered part of the marine environment, which is governed through the UN Convention on the Law of the Sea, which most countries in the world are party to, 165 out of 190 or so. Not the US, although the US recognizes most of it as what's called customary international law, which means unwritten international law. It's legally binding, but maybe we might disagree on the details, but we've got the general sense of things. And there's multiple obligations under the UN Convention on the Law of the Sea and presumably under customary international law to prevent and reduce pollution of the marine environment, for example. Second, there's a customary international law of transboundary risk. So countries that approve or undertake an activity which pose a significant risk of transboundary harm to another country. They don't have to be right next to that country, and that activity doesn't need to be taken in their own country. They could be approving it or undertaking it out on the high seas. They then have a number of obligations. They don't to control and reduce that risk. Advanced environmental impact assessment, notification, consultation, et cetera. They're not prohibited from creating transboundary risks because that happens all the time. So those two conventions operate as, the UN Convention on the Law of the Sea is a treaty, customary international law is unwritten, act as something as an international law backstop. They're probably not sufficient to completely govern solar geoengineering, but fill in a lot of gaps. I think we had a question.
We're actually out of time. But you're welcome to hang out and ask Jesse your question in an informal Q&A setting. Thank you for coming to our event. Our next one is December 13th, where ASU professor Jesse Senko will discuss innovative conservation efforts in fisheries management. So we hope to see you there. Thank you.
Thank you. Can I get your question? That surprised me. I thought I had 15 more minutes.